Good afternoon to the guest of honor, respected dignitaries, and all audience here. I request Dr. Badal Soni, who is currently working as Assistant Professor in the Department of CSE and IIT Silchar, India, to please address the gathering.
Okay, so good afternoon, all of you. So yes, we are just close to the closing ceremony, so it is very difficult to address the audience when we are supposed to end the session and the program. Already, I think so many lectures, so many talk, and many technical sessions is already over, and we are again come to the same things. So that I took actually the title of my presentations, the foundations of machine and deep learning with some real-time applications. Okay. So because as I discussed with Anji, so Anji told me to take some kind of this one, some kind of specific applications part. So I feel that that will be very difficult because some may have the interest of the particular applications or some kind of research work where my scholars or my team is working, and others may have some issues with that. Maybe they are not very happy. So just I would like to just revise the things which we have seen in last 2 days, and then finally we'll discuss some of the applications. Okay, so I'm audible there. My voice is coming there also. Okay, fine. It is clear. Okay, so next slide. So I will start with that introductions of my institute where I am actually working. So I am working at NIT Silchar. It is located into that northeast part of India, which is Assam Silchar. So we have very good, beautiful green campus here. So that are actually surrounded by many tea gardens are there, and that institute has placed there. And it has already many lakes are there. You will see that inside the campus itself, we have 20 to 30 lakes are there, where many water bodies, you can see that natural way they are flowing, water bodies are there, and different kind of beautiful flowers are there. And also we have big resource centers. This is called your learning center, center library. So it is actually it is Asia's biggest research this library is there. Once if you have a chance to visit, so definitely you should visit this library. This is very big library. I cannot explain much here, but I will welcome you to see you if you are coming to Silchar anytime. And talked about the institute, it has NIT Silchar recently in the year 2022, it has got 38 NIF ranking in place of engineering institutions, and overall it is having 76 in all India levels overall category set. Next slide. So these are the research area where my groups actually are working. So we have image processing, computer visions, machine translations, especially the fake news detections, multimedia security, human activity recognitions, and various applications of machine learning and deep learning in a healthcare domain. So these are some of the areas where my research group are working. Next. And we have a lab setup also. I am coordinating this lab as a very well-known lab, and where my scholars are sitting. They are doing their computational task. We have good computational facility in that lab. So some machines are there which will having like RAM of 64 GB RAM, 128 GB RAM with GPU processor support of 8 GB and 16 GB also. So for because we are talking about the deep learning, AI, and machine learning. For that, we need to have the computational powers. We need to train our models with high volumes of data. Without the computational power and computational facility, is very impossible to work with the deep learning architectures and the model. So this setup is there. So where we are executing some kind of real-time applications are also running in the lab. So to start with machine learning, we have to first see what is learning. So what is learning? Everybody knows what is learning. What is learning, madam? Acquiring some knowledge. Okay. Knowledge. Okay, so that is learning with improved performance. If the performance is not improved and we are acquiring knowledge, that is not a learning. So we are always looking for the performance should be improved every time. So there are two ways of learnings, maybe the inductive learnings and the deductive learnings. In the inductive learnings, we arrive to a conclusions by the process of generalizations. What does the mean of generalizations here? So basically, we have some kind of fact are there. Like for example, if we see that all the crows I have seen are black in color. So if we come to some kind of generalizations of these things, so we can say therefore most of the crows are basically black color. So we have come to the some generalizations using the fact. So this is called your inductive learnings. Similarly, we have the deductive learnings where the deductive we will come some valid reasonings also there in that to deduce new information from the data of fact. So for examples, we have all humans are immortals. And as I is a human, so basically it will comes to that conclusions that this one as I is immortal. So this called is basically that deductive learning. Next. So talked about the machine learning. So the task of machine learning is to come to make a generalized system, so generalized model, so that it will perform like well for any unseen data. So this is the major task of any machine learning. So what is the difference? Because we are earlier in the classical way of conventional learning, what we are doing, we are having the programs, we are having the code, and we are actually applying some logics in the to get that output of the program. But in the machine learning, what we are doing, we are actually training the machines for certain kind of task without explicitly programmed. Okay. So it will have data as well as the results, and will comes to them some patterns. Next. So these are the different ways of machine learning. So as we know that supervised is there, where the classifications, regressions will be there. Then unsupervised, the clusterings and association mining, and we have reinforcement learning. So these are the some categories of machine learning algorithm. Next. Now come to this data pre-processing pipeline. So as the flow of any machine learning models will be looking like we should have a data set, and data set should be pre-processed. Then we will come to the training part. Then model will be trained, and then we will check the model testing part. Okay, but we can say that the data pre-processing is very crucial part of any model. If we are not doing the data pre-processing properly, so we will not get the the expected results we are looking. So there are many ways of data pre-processing. We have to check whether our data is corrupted or it is having some noise or not, and then we have to see the missing values in the data. Then data explorations. Then we have to see that detecting some outliers and removal of the outliers present in the data. Then solving the class imbalance problems, feature set analysis, data normalization. So this is a very complex process. Data pre-processing is not easy task. So there are different steps are there. Total 7 steps are there. So because we cannot work onto the raw data is there. If we are working in the raw data, you cannot get the expected outcome. So before making a model, before training a models, you must do the data pre-processing. Okay. Come next. So what about this? What is this data removal? So removal of noise in the corrupted data. If we have, so these are the examples is given there. We are seeing that some of the corrupted data is there as well as some is the noisy data is there present in our data sets. So before processing this data, we have to go for the removal of the noise and removal of this corrupted data. Next. I'm quickly going because this is already we know, so I'm just covering so little bit. Next, we have missing values present in the data. Once we have a missing value having in the data sets, that is very difficult to actually train the models. We are training, that will give some kind of errors, we will have misclassifications in the results. So before that, we need to handle these missing values. So there are ways to handle the missing values. One way is to deletion methods, another way is the imputations. In the deletions method, what we are doing, we have the data in the text format. If we have Excel like rows and columns are there, if that missing values present in the rows, we have to go by deletions of that missing values. But it leads to some kind of problem issues are there. If you have many missing values present in the data and you are deleting many rows from the data sets, ultimately you will lose the information. So that is not an advisable forms to go with the deletion, but we have also imputations is there. In the statistics, imputations means we have to see the alternative form. If we have some missing values, we have to come up with the alternative values that will be replaced. In place of missing values, we have to replace with some values. That values will become statistically. So we have to. There are various methods are there like maximum values, minimum values, averaging values, mode, KNN, median. So what we have other data sets also there. From others values, we have to come up with some new values that will be replaced by missing part of the data. Next. Now outliers, there may be a local outliers or the global outlier. Local outlier are the outliers points which are near to actual value, and globals are there, they are very far from the actual value. So these need to be identified and we have to remove the outlier present in the data set. Next. Now we have class imbalance problems. So class imbalance problem is just a problems where we have data sets. If we talk about any binary class problems, so we have two classes in the binary problem. Maybe let's suppose S class and no class, two classes are there, and we have a data set where we have a majority of the S classes are there, and very few cases are there where the class is no class. This kind of problems or issues is called your class imbalance problem. So we have to tackle the class imbalance problems or before going for the training of the models. Okay? So how we can handle these issues present in the data? So there are ways like samplings. We can go for undersamplings, oversamplings. In the undersamplings, what we are doing, undersamplings, we have to actually in the majority class, what we are going to reduce or we are going to delete some of the data present in that majority class so that we can go up to the balanced class. And oversampling, what we are doing, we are replicating, so we are creating some more values in that minority classes and adding into the minority classes so that data set will be balanced. Other way of this is the algorithmic way. In the algorithmic way, what we are doing, we are actually having the algorithms, we will have some weightage factor. So what we are doing, we will give the less weight to the class, we will be having the majority, and we will have the more weightage to the minority classes example training samples. Okay, so in that way we can algorithmically we can handle these situations. And another way is the ensemble learning, okay, or ensembles way of handling this thing. So ensembles where we will have bootstrap or basically the bagging methods and the boosting methods to solve this data imbalance issues. Next. Now after this part is over, we have to go for the feature set analysis. So there are different way, features constructions is there, features extractions, then feature selection. So what are the difference of these features constructions, extractions, and then selection? So the constructions, we can create new features from already present features. How we can be having the data? Example is given A and B. Features is given to us. We can create some new features by using the existing features A and B. Example is given is self-explanatory. And similarly, we have a feature extractions where what we are having, we are actually keep some original features. We will keep the new features and we are discarding the original features. So that is called your features extraction. Some part of the features we are taking and some part of the features we are ignoring. Then feature selections, if we have the redundant features present in the feature set, we can come up with that basically the selections method. So that will select the subset of features to reduce the redundancy present in the feature sets. Next please. Now data normalizations, as we know that we have a variety of data that the values of the data may be varies from some range to some other range. So to come up with some kind of uniformity in the data, we have to normalize the data in some range. So generally we are keeping the data range into 0 to 1 or maybe -1 to minus. Okay, so there are ways for doing the data normalizations. Next please. Now supervised learning, so we have classifications and regressions. Next repetitions. Next please. So this is that more specific definitions of the classification. Next please. Decision tree, already we know that there are different methods are there for this one. So decision tree is one of that supervised learning methods where we have different way of things like we have like C4.5 decision tree, we have TART algorithm is there. Okay, but TART is nothing but a classification and regression techniques are there. Okay, next please. Next. So this just I will see this one slide for the decision tree. So we have here in the decision tree we have the root node, then we have the internal nodes. So internal nodes are basically the some attributes. Okay, you know the attributes, fine. Then we have edges that will reflect the values for the attributes, and finally we have the external node that will give the outcome of the classification. Okay, final node that will be the leaf node. Next. Next. This is also provided. Reinforcement learning is what is the reinforcement learning? This is basically the agent-based learning. So where the agents will try to learn from that basically from the environment it behaves, and it will wait for that that which kind of actions is performing and what kind of rewards are giving to that. So that agent is trying to learn from the environment. Next. So now come to that model training. So generally in the entire data set we are actually having the splitting training set and the test sets. So 30, 70, 30, 80, 20, 90, 10 generally the issues are there. And we have k-fold cross validations. What is this k-fold? K-fold. What we are using the k-fold? Partitioning of the data. Okay. So what we are doing in the k-fold, so we are actually partitioning entire data sets into some fold. Let's suppose for the k-fold, k number of sets will be there, where what we are doing, so one set will be representing as a test sets and other set will be the training sets. Finally, it will be repeated for the k times so that it will we can check the validations of the model sign. Next please. Model evaluations, we have the confusion matrix, true positive, false positives. Next. Okay, so this machine learning is finished. Now, okay, we come to some deep learning. Okay, next, please. So, what is deep learning is actually the part of machine learning only. It's actually the subset of machine learning, and we will see in the deep learning. Basically, we need some kind of neural networks. Without, it will have a connect many kind of layers with hidden layers will be there, and from that we are actually applying some weight concepts. So weight will be actually makes the neural learns, and then we will get that our task will be fulfilled and what kind of applications are there. So now we'll discuss about the applications of deep learning. So we know that deep learning is nowadays in everywhere. So we have like we talked about internet and clouds. What kind of deep learning? So what we are using the deep learning. So we have like image classifications, speech recognitions, language translations, language processing, sentiment analysis, and recommendations. So what is image classifications? What kind of image classifications are actually used in the internet and then maybe in the clouds? We are using the Facebook now. So in the Facebook we have features like it will classify the image automatically. We are uploading the images like different kind of images, some kind of natural images, some kind of images from the sport background, some kind of images are basically the sea images are there, water rivers images are there. So what they are doing, they have actually based on that they have the deep learning models there. So what they are doing, whatever we are uploading, that automatically this image will be actually test in their data sets. So that will divide that image or classify your image into some categories. Which kind of image is this? So that is basically the image classifications. And we talk about the speech recognitions. Nowadays, speech recognitions are heavily used. People are using the voice search. They are doing the voice search. So what is happening in the voice search? We are speaking to that through the microphones, and our voice is actually go to the systems, and where this voice will be converted into the text part. Okay, so the voice to text conversion is there. Once this text conversion is there, so using some kind of natural language processing, that model is actually try to map your whatever you want to search, map your data into the cloud, and based on there that you will get some kind of outcomes. So this kind of things basically we are doing, but we are not sure, but because how much computational is required for doing these things. So hello, slide, not previous slides. Previous. Next. Okay. So that is your speech recognition. Then we have language translations. In the language translations, what is happening? We have input in one particular language, and we are looking for the output in some other language. That is called your language translation. So when we are Google Translator is there, everyone is using the Google translations. So we can see that basically many research is going on for that language translation, or it is called your machine translations. Okay. Now we can see that in India, basically we are actually in the it comes to the category of the low resource languages. Low resource languages are the languages where we have very limited level data. Okay, so we have like Manipuri is there, we have Assamese is there, Odia language is there. So it's a variety of languages are there. So the research is actually going on and to provide a perfect solution, because up to now we do not have any translator who will translate 100% perfectly whatever we are doing. For some kind of limited data sets, it is okay, fine, it is working fine. But if we talk about in some kind of real data set, the people are giving, it is basically not giving 100% accuracy. Okay, so the research is going on in this language translations. People are working. Then we have language processing, sentiment analysis. Now, sentiment analysis, very that product review kind of things. We are having while going for any kind of product purchasing, first we go for the product recommendations. What kind of reviews are there? So where basically the pupils are giving that their feedback kind of things, their sentiment about the product, what kind of things are there, and companies are also trying to learn from the data of what kind of reviews are customers are giving to improve their product qualities as well as to target a particular uh, a particular kind of customer so that they can attract the customers while recommending their product into the requirement of the customers or the users. And also this deep learning is also useful in kind of healthcare domains where the people are using for cancer cell detections, then uh, maybe the diabetic and the drug discoveries also. There's many applications are there. People are using the deep learning in the healthcare domains also. Okay. Then media and entertainments, that where the video captioning is there. Do you know the video captioning, image captioning, video captioning? All of you know what is this happening in the image captioning? From that object itself, the model will be trained to generate the captions automatically. So what will be the captions for a particular image? Then we have security also, the face detections, video surveillance. So these all areas are there where these deep learnings are heavily used. This next slide. Okay. So when it comes to that, the deep learning, so basically is actually the neural networks where we have an input layer, hidden layers, and we have the output layers. So the weights are there that will be actually multiplied with that input layer, and then we will have the activated function to get the final outcomes. Next. Okay. So these are the characteristic of any neural networks. It should be having learned from the examples. It should be adaptive in nature, then robust, fault tolerance. It has the capacity of generalizations, and it exhibits mapping capabilities. Then massively parallel in nature. It should be parallel in nature. Then neural networks are non-linear in nature. Next. So these are the differences between BNN and ANNs, biological neural networks and the artificial neural networks. So basically, these are the difference where BNN is very huge in size, ANN is comparatively less than the BNNs. That the BNN is having the complex topologies and it is asynchronous in nature, where that ANN is having the topology like a tree structures. ANN is slower, this BNN is slower than ANN, and ANN is much faster than BNN. So these are the some kind of difference between biological neural networks and artificial neural networks. So we will come to the first, basically McClush and Pitts models that is actually proposed by in the year of 1943. It is a basic models. Initially, it is given. So here we have basically the input, and we have kind of summations kind of things, rules, and we have the threshold to get the final output. So in this particular initial model, there is no concept of weight is there. Okay. So that output is depends upon the thresholds, which is actually determined manually. So based on that calculations, we should have compared the our results with some kind of threshold, and that will decide the perfect what should be the output of these models. So for this, we have one example is there. So one situation is there where the persons, whether a persons need to take a rest after doing certain activities or not. So we have four activities: X1, X2, X3, X4 here. Where X1 is actually walking for 2 hours, running for 1 hour, then taking lunch or dinner immediately, and X4 is actually doing yoga for 1 hour. So these are the activities are there. So using these models, what that we have to pop up that output, what should the person should do, that decision should come. So manually we have to come to the threshold selections. So for these models, we have for these examples we have decided that our threshold should be 2. If okay, the summation is less than equal to 2, then if it is greater than equal to 2, then okay, that person should go for the rest, otherwise no. So like that. So results are there. It is in binary nature. So all the inputs are in the binary, and we'll compare the results which threshold true, and we get the actions accordingly. So these are some limitations of this model. So it cannot handle non-Boolean values. Threshold must be defined manually, and importance of all inputs are same because there is no weight concepts are given. So equally all inputs are equally weighted, and we cannot assign a certain or more importance to a specific input value. Next. Next, after that, in continuations of this McCulloch-Pitts models to overcome the limitations of McCulloch-Pitts models, Robertson-Platt's perceptron model is there, where the concept of weights and automatic threshold calculations is there. So we have the weight concept is there, as well as the automatic thresholding concept is also. Now we talked about the activation functions. So when we are going for the deep learning architecture, so we see that the role of activation functions is there. Without this activation functions, basically, okay. So that will actually the activation functions will normalize the values either in terms of 0 and 1s, or it may be -1 and 1. Next. So we have different kind of activation functions like binary step functions. Then we have ReLU functions, softmax, etc. So in the binary step functions, so we are actually having actually the linear functions here. So we will get the output calculations. Then we will apply this step function. So that will convert the data either in 0 or 1. Next. Then we have a ReLU, that is actually your rectifier linear units. So what will happen? So for all negative values, the ReLU activation functions convert all negative values to the 0, and it will convert it will keep only the positive values, okay, in the ReLU activation function. So all negatives will be converted to the zeros, and it will keep the all positive values of it. Next, but it has the problems of dying ReLU. So what is this dying ReLU? Dying ReLU. Dying ReLU issues. So what is this dying ReLU? So in the ReLU functions, as what we are doing, we are actually we are converting all negative values into the 0. So that is the constant line. In that our data, if we have a majority of the negative values, so all will become 0. So that will give the constant lines. So this issues is called your dying ReLU. Okay. To resolve these issues, what we are having, we are having one more additions of ReLU function, that is called your leaky ReLU. Okay. Next. So in the leaky ReLU, what we are doing, we are actually adding small slope using a constant, okay, that will be set by user itself for all negative inputs. When we are having the negative inputs, what we are doing is we are adding a small slope while multiplying some constant value to the negative values, so that we'll get something. Some values will be there. It will not be replaced by 0, because some of the values, small values will be there. So it will be close to 0, but not actually 0. Okay. So that will resolve the issues of your dying ReLU. Okay. Now we'll see that what is this back propagations in neural network. So what we are doing in the back propagations way, for model fine tunings, what we are doing, we are actually giving the will check the calculations of error. What kind of error is coming? If the error is there, so the model is going to again changing some parameters, or this is called your hyperparameter tuning. So what is the objective of this backpropagation algorithm? So we are going to minimize the error as much as possible while doing the hyperparameter tuning. Next. So in the deep learnings, we will have multiple hidden layers as a neural networks that will having the features like automatic features engineering, very less human interventions is needed here, and it will better performance as compared to the shallow learning algorithms provide. Okay, sufficient data is passed to the models. Okay. So next. Now, so deal with that, we will discuss what CNN, convolutions neural networks. So how this network will work and how this deep learning architectures will work. So basically, the CNN is heavily used for image process, image kind of analysis. Image whenever we are having the image data set. So by default, we are using the CNN architecture. So what is this? This is convolutions neural network. So we are having many layers of for the convolutions. Convolutions basically kind of a filter analysis where we are having the image and as well as we have some filter marks that will the filter marks will be convolved with the image input and will get the convolved output. Okay. So as much as we have that convolutions layers, we are going to have more kind of specific features we are actually extracting from the image and we are going to process that more meaningful features others layers. So these are the main operations in CNN. So first we have a convolutions operations, then we have a pooling or subsamplings. We have second we have a rectilight ReLU functions, then pooling and subsampling. Finally, we are actually going for the classification of the fully connected layer. So that will actually flatten the results. Okay. So these are the way of actually arranging of different layers in that deep learning architecture or CNNs. Next. So this is the convolutions functions is defined in this particular slide. So where we are having the image and the filter mask is there, which will be convolved to get the convolved features of the image. Next. Okay. So these are the three parameters are there like depth, stride, and zero padding. So depth is basically this correspond to that number of filters we use to the for the convolutions operations. The number of filters extracts more features. The network becomes better at recognizing the patterns in unseen images. Okay. As many as that we have the convolutions layers, that will become more better for recognizing that image in the unseen data. And then stride is basically the how number of pixels by which we slice the filter mask over the input matrix. So how many pixels we are actually sliding to make to get the convolved images. So that is called your stripes. And then zero padding is required through additions of zeros into the boundary of the input matrix so that we can to get the proper borders to apply the filtering or convolutions process in that image. Next, please. The value functions, what does you do? So we have that inputs in this particular examples. We are seeing the input is there 2 minus 1 3 4 2 minus 5 and 6 minus 8 1. So what is there? So you will see that what are the negatives or these negatives values are there, attributes are there, that is replaced by the zero values. So it is actually converting that negative attributes into the zero. So that is that the ReLU function is doing. Next. After that, we have pooling is there, pooling operations in the CNN. So that is called your subsampling or downsampling, basically. So here we can see that first corner of this matrix 12, 20, 8, 12. So what we are doing here for this pink class, we have actually applying the max pooling of 2 by 2. So it will replace this 2 by 2 by a single values of 20, which is the maximum values of this 2 by 2 matrix. Similarly, for the other subsamples 30, 0, 2, 0, it will be replaced by 30, and then 34, 70, 112, and 100 will be replaced by 112. And similarly for rest, the 37. So it is called your max pooling kind of operations, which is performed after the ReLU functions, ReLU operations. Next. And then we have GPU deep learning, so that is stored in the matrix, and GPUs are made so to do the parallel processing of the parallel programs, and this is extremely boost the performance in the parallel computations. So these are I just discussed that what is the operations are performed in the CNN. So some more operations which we see, and after that we'll see some of the applications of deep learning. Okay. So these are the applications of deep learning, machine learning basically. So we are having the recommender systems are there, span filtering is there, automation driving is there, disease predictions, digital tools and object detection. So automatic driving is now like the company like Tesla, they are actually coming with kind of so I'm talking about this one, automatic driving. So Tesla is basically coming out with a driverless car. So what is happening is that how they are actually coming with that kind of driverless concept. So they have a basically the deep learning architecture, deep learning models are there. So where the model is trained with huge amount of data. So they have the data about the distance of car, data about the objects inside the road or traffic, data about the traffic signals. So these all kind of data they are actually keeping in that for the training purpose, and they are training with that models, and that is coming with the concept of the driverless car. So the sensor are there. They are actually reading the data, real time data, and within a very fiction of time, the data is actually processed with the models or the device. This is located into the your car, and that will go to the cloud, and the cloud are actually processing and giving that proper what to do, whether to go for the left turns or whether to go to the right turns or whether to stop. So this kind of these structures or that is requires a huge amount of data processing. So they have the good infrastructure, the computational facilities are there. They are coming with this kind of solution. So we can also think like that, but the limitation is that we are very we are facing the issues with the computational issues where we will come, we will do the modeling part, where we will do the training part. So this is the issues where India actually we are facing, but maybe now the concept of kind of cloud computing kind of thing is there. So where we can run our programs in the clouds. Nowadays, people are using the Colab, Google Colab is there. So they are providing that GPU computations up to 16 GB, and also they have some kind of Pro Colab is there. So we have our options. We can do our if we are having some kind of thoughts of doing of this kind of computations, we can still do while going with some alternative way, even though physically the resources are not available, but we can go with that kind of online supports or the cloud supports where the companies are providing. So there is a way. Next. So recommender system. So we have discussed these things. Next. We now I'm just talking about that what kind of research is actually going in my lab. So these are the some PhD scholars, full-time PhD scholars. They are doing. So this is first one is Candy Lalarampai. She is from Mizoram, and she is doing basically machine translation. So especially as she is Mizo girl, so she is actually doing actually developing a automatic systems or models who will translate the Mizo sentences into the English as well as English to Mizo, vice versa. Okay, because we see that in that currently research in the literature side, we go very little work is done in this particular domains. There are work in the language translations, but not in Mizo. Okay. Other languages are there like Hindi, English, Punjabi, Bengali. We have the translator. We have the publications in particular domains. So people are working. But in like northeastern language like Mizoram, there are very few papers are there where this kind of work is going on, and she is doing this using the concept of open NMT is there in the Python. So We have a transformer models. He developed the transformer model also for that work, and that work is also published. Next. So the few of the publications from these works we made it. Next. Next my scholar is actually she is working with brain hemorrhage classification. So these actually taking basically the images, MRI images, brain MRI images. We have a collaborations with that Kachar Cancer Hospital. So we are getting the real time data from there. So this is actually going for identifications of the hemorrhage and then the classifications of the types of hemorrhage present in that patient's image of MRI images as well as the CT scan images. So she is using the concept of transfer learning for her work. Few of the publications also be made for her work. Next, please. Now, one more scholar is there, Iduri Rajas. He is working in kind of NLP domains where the fake news detections is there. So we know that in nowadays in the social medias, now the fake news is populated heavily. So that main intentions may be misleading the audience or providing some kind of erroneous information to the public, so that make that news will becomes viral and it will be some kind of companies are e-commerce companies are making some benefit from there, and to just get the more hits on their websites, on web pages. These kind of news are actually populated in that social media sites. Now, the objective of this work is to identify the news which are actually fake in nature. So he is working in this particular domain. So basically, he's applying some kind of deep learning RNN networks like LSTM, ILSTM models is actually doing, as well as multilingual kind of thing is also he's planning to do, where multiple languages are will be there, like code mix data will be there. What is code mix data? You know the code mix data? So we have a data, let's suppose if we have a English, so only English sentences are there. So that is called, okay, it is an English data sets. If we are in the social media, what we are doing, we are actually writing in some code mixed manner, not in a single language. While let's suppose the Hindi regions people, they are actually using some kind of Hindi words along with the English. As some others peoples, they are actually mixing their local language, their mother tongue, they are mixing with English. So that becomes the code mixed data. To train the model with this kind of code mixed data is very difficult, because for one language, for English or any other language, okay, we know the features of the language, we know that what kind of complexities are there, what kind of instructions are there in the sentence. So we will come up the solutions to make a models for a specific language. Once if your data is code mixed, because this code mixed data is the collections of two or more languages data, then it is very difficult to handle this kind of data. So now the people are working to provide the solutions for the code mixed data, not a single language data. Okay? So he is trying for working and giving a solutions also for kind of the detections of fake news, basically in the Dravidian languages. So he is actually targeting the Dravidian languages as well as the code mixed languages. Next, please. Next slide. Okay. Now, one more scholar is there. Actually, he is working in this human activity recognitions. So, what is this human activity recognitions? So, we are doing different activities like walking, running, jumping. Okay, step down, step up. So, there are so many activities are there. Now, we have to come up with some kind of solution so that human activities can be recognized. So what is the objective of human activities? Why we are doing this recognition of human activities? Maybe there is a situation we can see that kind of basically elderly persons are there. Okay, so they are actually nowadays the people the elderly persons are in that home, and the people who are working, they will go out. So now the concept is coming the wearable device. Okay, so what are the wearable devices? The people are using the wearable devices that will be in touch with the body, and from the body itself they are actually capturing real-time data. Okay, so providing some kind of health informatics support, like they are giving some like useful information about monitoring the health records, that their BP, their heart conditions, and their sugar level. So many things are there. Okay. So from that data, they wear and device, the data is actually captured, real time data is capturing, and that is actually processing. That the data will be, that sensor will collect the data, and this data will be go to the cloud to for the processing purpose. Once some kind of let's suppose if we have the data of elderly persons of like we have a different activities like they're running, jumping, or walking, kind of things we have recorded. The trained data is there. The model is trained for the person, specific person. Now, if some kind of uneven activity is happening, let's suppose the person is fall down, so maybe the sensor will record some other data, so that will be categorized as the fall. Okay, so the data will be go to the cloud for the processing, and that will indicate some kind of alarm or some kind of signals, so that the person, the relative of that person will get to know some kind of uneven thing is happened, so that they can provide the immediate health support to the person. And in this manner we can come up with the solutions to get at least some kind of support, so that we can provide the primary health, and we can save somebody lives also. So these kind of applications are there for human activity recognition. So he's targeting that problems and providing the solutions for this one using the wearable device sensor data. Okay. So so these are some publications which already we made in this particular domain. Next, so now sir, so thank you for your patience to listen me, because it is very difficult to take the talk at the last of the sessions or the last of the program, because already the people have become fed up by listening so many things. So now they want okay, the closing ceremony should be done as quickly possible. So thank you very much, and you can contact me for any issues. I am open for the questions. If you have the questions, you may please ask. Or I am also inviting you people to at least visit Silchar and NIT Silchar. I will be there to welcome you. I will be happy to welcome you. If you have any chance to come there, you can come. We are also organizing the conferences, workshops, training programming. Very maybe that occasionally we are organizing. Every semesters we are all targeting organize one conference, international conference from the department itself. So computer science department and IT centers every semesters one conference we are organizing, as well as so many programs are actually we are conducting through like DST funded, self funded, and we have. I am also proposing one conference, that is one proposal for this high end workshop. You know that this one Karisala, DST Karisala. So it may be in May 2023. So where the it's basically that UG and PG students will get the, and as well as the PhD student will get the support for travel as well as the accommodations and their lodging and boarding facility. So they are just to come without any charge. They can have the experience with the interactions of some kind of expert of domain expert. You can meet with some kind of industry person as well as some kind of basically the IIT and IIT professors. You can interact with them, and you can enjoy at least your 1 week or 2 weeks while attending that program. Okay. So the details I will share with Anji, so he will circulate the soon to all of you, and I will be happy to welcome you. Thank you very much.
Thank you, sir. It was a meticulous session. You have shared the machine learning and deep learning basics, along with sentimental analysis and applications of machine learning. We are immensely grateful to you for sharing your research scholar works like human activity recognition and fake news detection. We are spellbound and truly inspired by your study. Thank you.
మంచిగా